Here we have the times and the scores with regards to 1, 2, 3, 4, 5, 6, 7 students. So, for example, student number 2 studied for 4 hours and they got a score of 89%, while student 3 studied for 6 hours and they got a score of 88%. So here we have two variables, time and score. So time could be considered the X variable or the independent variable, and score could be considered the Y variable or the dependent variable. Score depends on time. So we could measure the relationship between time and score. To what extent does time affect score? Okay. And this can be done using coefficient correlation and coefficient of determination, and we can do another analysis with regards to the slope and the y-intercept of the equation of the line of best fit to further the analysis between the way that time is affecting score on a quantitative level. So for the coefficient correlation, we can go to, if we want Excel to put it here in D1, we click on D1, then we go to insert, or no, formulas, insert function, and then we click on here, most recently used, and we look for statistical, all right, and we look for Pearson's correlation, Pearson's correlation, okay, and we click OK. So Pearson is asking us array 1. So array 1 is from A2 to A8, so we can click on A2 and scroll along, double click and hold to A2, A2 to A8, and array 2, that's the dependent variable, right? Here it is. If you look, click here, the independent values, okay, which is time, and array 2, dependent values, as you can see, which is score. So we click on B2, double click and hold, and drag to B8, okay, and automatically Excel has calculated the coefficient to be 0.69. So if we click OK, here it is, 0.69 as the coefficient correlation between time and score according to these values. If you want Excel to round it off to 2 decimal places, we just click on D1, right click or shift F10, and we go to format cells, and we go to number and 2 decimal places. Let's put 3 decimal places, click OK, and Excel has round it off to 3 decimal places. Now the coefficient of determination. To get the coefficient of determination is actually the square of the correlation. So we can type equal, and we can type, click on D2, raised to the power of 2, enter, okay? And what Excel, we will type shift F10, and we round off to 2 decimal places. Let's see what happens. Round off to 15. Excel gives us 15 decimal places. Let's put 3 decimal places, and here we have it, 0.480. Okay, the coefficient of determination, which is the square of the correlation. Now the slope, now we can get the slope by actually going through that's one way, using the scatter plot way. So we go to, we don't really have to type on, click on D3, but we can. Then we go to insert, then we go to charts, insert scatter plot. So what we're going to get is a scatter plot indicating, but we have to indicate to Excel where the scatter plot, the values for the scatter plot. So we have to highlight time and scores. Time is the X, goes on the X-axis, scores goes on the Y-axis, and then we go back again, insert, charts, make sure you highlight it, time and score. Excel, it was not highlighted, so Excel didn't know which values I would like to put on the scatter plot. All right, these are the X and the Y. So make sure these two sets of values are highlighted, and then you go back to scatter, and here it is. On the X-axis, you have the time, and on the Y-axis, you have the scores. And then try to get the line of best fit and the gradient and the Y-intercept, okay? You go to quick layout, make sure you go to chart design. If you're on home or wherever you are, make sure you click on the chart and go on chart design, and then you go to quick layout, and you go to this one there that mark layout 9, shows the following chart: the title, the legend, the series, horizontal and the vertical, and also the function. Okay, so here it is. And as you can see, look, the coefficient of determination R squared 0.4799, 0.48, and the Y-intercept and the slope. The slope is 3.4375, 3.4375, okay, and the Y-intercept is 70.813, okay, and actually gives you the equation of the line of best fit, which you can use to forecast, okay. And as you can see, there's a positive correlation between time and score, and it's strong positive because it's more than 0.5 according to these values. So as the time practicing increases, your score actually increases, okay. You have a slope of 3.4375. This means that with every hour that you practice, your score increases by 3.4375. That's what the slope means. I repeat, the slope means the 3.4375 means with every hour that you practice, your score increases by 3.4375 with every 1 hour that you practice. Okay, and the 0.48 now, the coefficient of determination, means that 48% of the change in score is due to the time practicing. Okay, so that's like a strong correlation. And the 70.83, the Y-intercept, means that if you don't study at all, you most likely might get a 70%. That's what the 70.83 means. If you don't study at all, if your time practicing is 0, then here's the Y-intercept goes right there. You might get a score of 70. But with every hour you practice, your score increases by 3.4375.